Hi everyone, welcome back to Learner's World. Today's video is over the integumentary system. If you are someone who likes to take notes, I have a fill-in-the-blank worksheet linked in the description box below. So without further ado, let's get started. The basics of the integumentary system. So the function is to protect the body and regulate body temperature, and the main organ is the skin. So the skin forms a protective covering over the body, which prevents infection and water loss. It allows for us to sense our environment through touch. Due to exposure to the sun, the skin aids in the formation of vitamin D in the body. The integumentary system aids in the regulation of body temperature by 1. The blood vessels in the skin helping to release or hold heat, and 2. Perspiration or sweat being released to keep the body cool, and skin shivering to keep warm. The integumentary system is made up of skin, nails, and hair. Hair and nails both are made up of a protein called keratin, and hair, the keratin, grows in the follicle. Hair is found all over the body except lips, palms, and soles of feet. Functions include warmth, protection, and immune defense. In nails, keratin grows from the root. This is found on fingers and toes, both of which are known as phalanges. And functions of nails are protection, and they are a tool for precise activities. Skin. Your skin is the largest organ of your body, and it's made up of 3 layers of tissues. The epidermis, being the outer layer of skin composed of epithelial cells. The outermost cells are dead and rub off. New cells are constantly made at the base or bottom of the epidermis. Melanocyte cells in the epidermis produce melanin, which is a pigment that protects skin and gives it color. The second layer, being the dermis. The dermis is composed of connective tissue, nerve fibers, muscles, oil glands, and sweat glands. And the hypodermis is the fatty layer below the dermis. Quick little facts about the integumentary system. So in the skin, there are 15 feet of blood vessels, 4 yards of nerves, 650 sweat glands, 100 oil glands, 1,500 sensory receptors, and more than 3 million cells with an average lifespan of 26 days that are constantly being replaced per every square inch of skin. The name stems from the Latin verb integer, meaning to cover. The relevant Greek and Latin roots include dermato and cutis, which both mean skin. The epidermis. The epidermis contains no blood vessels. It is made up of layers of closely packed epithelial cells. Contains 5 layers of cells, which are the stratum corneum, stratum lucidum, stratum granulosum, stratum spinosum, and stratum basale. These I have listed from most superficial to the deepest. And one way to remember the layers is Californians like girls in string bikinis. So the stratum corneum is 20 layers of flat, scaly, dead cells. These cells represent 3/4 of the thickness of the epidermis and are said to be cornified, meaning that they are tough. So this layer is found in both thick and thin skin, which we'll get into thick and thin skin a little bit later in the video. The stratum lucidum is translucent layer of dead cells. It contains ellatin, which becomes keratin as cells move to the stratum corneum. The stratum granulosum contains 3 to 5 layers of flattened cells that contain keratohyalin, which is a substance that marks the beginning of keratin formation. No blood vessels go this far into the epidermis, meaning cells are either dead or dying by this layer. The stratum spinosum, aka the spinous layer, is 5 to 10 layers containing spinous or prickle cells. These cells are named for their spine-like projections that connect them to the other cells of the layer. Langerhans cells, which are involved in the body's immune response, are prevalent in the upper portions of this layer and occasionally the bottom portions of the stratum granulosum. The stratum basale is also known as the stratum germinativum. It is referred to as the germinal layer because this single layer is composed of cube-shaped stem cells. This layer is the site of mitosis as the cells divide and push upward. It takes 2 weeks for the cells of this layer to migrate upward. It rests on the papillary surface of the dermis, close to the blood supply. A quarter of the cells in this layer are melanocytes, and the rest divide into keratinocytes. The dermis. It is a thicker fibrous structure, including fibroblasts, which are cells creating fibers that form the bulk of connective tissues, and macrophages, which are cells that engulf waste and foreign microorganisms. It's thicker on the back and sides than on the stomach and middle of the body. This is where accessories of the skin, so the hair follicles, blood vessels, glands, and nerves, are embedded. Adipocytes, or fat cells, are found at the bottom of the dermis, where the dermis transitions into the hypodermis. It contains 2 layers, the papillary layer and the reticular layer. The papillary layer contains areolar tissue that projects into the epidermis. The papillae increase the surface of the connection between the dermis and the epidermis basement membrane. Some of the papillae contain Meissner's corpuscles, which are nerve receptors that are sensitive to touch. The reticular layer is the thicker layer of the dermis. It is made up of dense irregular connective tissue containing interlacing bundles of collagenous and elastic fibers. This layer gives strength, elasticity, and extensibility to the skin. Sebaceous glands or oil glands, sudoriferous glands, which are known as sweat glands, hair follicles, larger blood vessels, fat cells, and nerve cells are housed here. Contains lamelated or Pacinian corpuscles. The hypodermis, aka the subcutaneous layer, or superficial fascia. It is not part of the integument. It is the layer deep to the skin, mostly made up of areolar and adipose tissues. It is technically not part of the skin. It anchors skin via fibers that extend from the dermis. It attaches loosely to tissues and organs, allowing muscles to move freely. It contains lamellated or Pacinian corpuscles. Next, we have receptors of the integumentary system. So, first receptor we have is the free nerve endings. This is the most abundant type of sensory endings, occurring widely in the integument and within muscles, joints, viscera, and other structures. Dendrites are the nerve endings or branch extensions of sensory neurons with a swelling at the end. Mostly function as nociception or pain sensation. Some sense temperature, touch, and strength. Found all over the body, especially prevalent in the epithelial and connective tissues. Next, we have Meissner's corpuscles. This is a light touch mechanoreceptor found within the dermal papillae. They are small egg-shaped capsules of connective tissue. They surround a spiraled end of the dendrite, most abundant in areas of sensitive touch like lips and fingertips. The Pacinian corpuscles are deep to pressure mechanical receptors found deep in the dermis and hypodermis. They respond to deep or firm pressure and vibrations. Each is more than 2 millimeters long, so they would be visible to the naked eye. The hair plexus, these are nerve endings that wrap around the hair follicle, function as mechanical receptors. When hair is moved, these nerve endings are stimulated, creating a light touch sensation. Hair. Hair is everywhere in the human body except for lips, eyelids, palms of hands, nipples, portions of external reproductive organs, and soles of feet. Hair grows from a follicle embedded in the epidermis and extending to the dermis. The bulb is the expanded base of the hair follicle where the nerves reach to. Epithelial cells divide into the bulb, producing the hair's root. Like in the epidermis, cells die as they are pushed away from the source of nutrients. At the surface of the scalp, the hair is referred to as the shaft. Melanin also provides for the color of the hair. Hair-wise, there are 3 types of melanin: brown, black, and yellow. Hair becomes oily due to the sebaceous glands. Sebum or oil keeps hair and skin soft, pliable, and waterproof. Each hair follicle is attached to a smooth muscle. This muscle is called the erector pili muscle, which creates goosebumps by straightening the hair shaft and elevating the skin. Nails. They are made of keratin. They have 3 parts: the root bed at the nail base, a body that's attached to the fingertip, and a free edge that goes beyond the end of the finger or toe. Heavily cornified tissue forms the nail from modified strata corneum and lucidum. Cornification is a process by which squamous cells are turned into keratin. A narrow fold in the stratum corneum turns back, forming the eponychium or the cuticle. The half-moon shape at the base of the nail is called the lunula, which is where the strata thicken under the nail. Beneath the lunula is the nail matrix, a region of thickened strata where mitosis pushes previously formed cornified cells forward, making the nail grow. The hyponychium is thickened stratum corneum found under the free edge of the nail. Glands. So you have sebaceous glands. These are oil glands. They are housed in the dermis. It releases a fatty substance called sebum or oil. Attached to the hair follicle is where you were most likely to find the sebaceous glands. When the erector pili muscle contracts, the pressure put on the gland can cause it to release sebum. Pseudoriferous glands. These are sweat glands, most numerous in the palm and soles of feet. There are 2 types, the eccrine sweat gland and the apocrine sweat gland. Both types are coiled tubules embedded in the dermis and composed of simple columnar cells. Eccrine sweat glands are distributed widely over the body. On average, there are about 3 million in an adult body. Apocrine sweat glands are located primarily in the armpits and external genital area. They release sweat into the hair follicle. They don't become active until puberty and are usually triggered by stress. Thick skin versus thin skin. Thick skin is found on the palms of hands and soles of feet. This contains all 5 layers of the epidermis, so stratum corneum, stratum lucidum, stratum spinosum, stratum granulosum, and stratum basale. It contains pseudoriferous glands, so the sweat glands, but it does not contain hair or sebaceous glands. Cells are tightly packed in thick skin and thin skin. It contains all but 1 layer of the epidermis, which the layer does not contain, is the stratum lucidum. Thin skin covers most of the body. It contains sweat and sebaceous glands and hair. Cells are more or less loosely packed here. Cells of the integumentary system are keratinocyte stem cells, which produce keratinocytes and other stem cells. They are the primary cell of the epidermis. They are non-dividing cells that undergo keratinization. You have tactile cells, which are sensitive to touch. Melanocytes, which produce the pigment of melanin. The epidermal dendritic cells, which are immune cells that help fight infection. They're also known as Langerhans cells. And you have corneocytes, which are dead anucleate keratinocytes that are found in the stratum corneum. Clinical significance. Starting off with skin cancer, most common type of cancer. There is a role played by genetics. There are 3 main types of skin cancer: the basal cell carcinoma, the squamous cell carcinoma, and the malignant melanoma. Basal cell carcinoma starts in the stratum basale layer, most common and least dangerous type, and it is usually benign. Squamous cell carcinoma is usually benign. It starts in the stratum spinosum, and it may metastasize. Malignant melanoma starts in melanocytes. It is the most deadly and most commonly seen starting in a mole. So there is an ABCD rule for detecting melanomas, and because melanomas usually start in a mole, the ABCD rule is going to be describing the mole. So A is for asymmetry of the mole, B is for border irregularity of a mole, C means the color of the mole is not uniform, and D is when the diameter of a mole is larger than 6 millimeters. So next up for clinical significance, we have burns. Burns are relatively common injuries that result from skin exposure to heat, friction, radiation, electrical shock, or strong chemical agents. There are 3 degrees of burns. First degree burn only affects the surface of the epidermis. Second degree burn is when the entire epidermis is burned off, and some of the dermis may be burned as well. You're not going to see blisters with second degree burns like you would for a first degree burn. Third degree burns, the epidermis and dermis are destroyed, and the burn extends into the hypodermis. Skin doesn't regenerate after third degree burns, so skin grafts are typically used. That's all I have for today. I hope you enjoyed the video. If you did, please hit the like button. And if there's a topic you want to learn more about, please leave it in the comment section below. Have a good day.